A geometric sequence, each term is found by multiplying the previous term by a fixed amount. Let us take an example here: 2, 4, 8, 16, 32, 64, etc. This sequence has a factor of 2 between each number. For example, we can see two ways. This can be expressed as a power of its position, okay, like 2 to the power 1 first term, 2 to the power second term, 2 to the power third term, etc. Or you can also see that this term is nothing but 2 times this one, and this term is nothing but 2 times this one, previous one. This term is nothing but 2 times its previous term, etc. Okay, so this sequence has a factor of 2 between each number, okay, factor of 2, okay. It is so hence we can write the rule as xn equal to 2 power n, n being the nth term, fourth term means 2 to the power 4, etc. Let's take another example, another one: 3, 9, 27, 81, 243, 729, 2187, etc. Let us take this sequence, okay. This sequence has a factor of 3 between each number. You can see 3 power 1, 3 power 2, 9, 3 power 3, 27, etc. Or you can say 3 into this number is nothing but 3 times this one, this number is nothing but 3 times this one, like that, okay. Hence we can arrive at a rule called xn, which is equal to 3 to the power n. One more example, like 4, 2, 1, 0.5, 0.25, etc. is another sequence, right? And this sequence has a factor of 0.5, half between each number. Like this is going to be the half of the previous term. Half of this is going to be the next term. Like that it is going on. Okay. So the rule we can put in here is the first term is going to be 4. And we can always say that half of that, right? So half of the term to the power n, negative n means is divided by that amount, okay. Yes, this is how the geometric example is. The only difference between the arithmetic sequence and the geometric sequence is in the arithmetic sequence, the difference between one term and the next is a constant, okay, like some constant number. But in case of a geometric, it is going to be a factor, okay, factor of multiplying the previous term by a fixed amount, okay? This is the thing need to be remembered. Let us see the formula component. From GP means each term of the sequence except the first is obtained by multiplying the preceding term by a constant factor, okay. Such a sequence is called geometric progression. The constant factor is called common ratio, okay. Let's take examples: 3, 3 squared, 3 cubed, 3, 4. What is the common ratio here? Common ratio R, which is denoted by R, is T2 by T1, or 3T divided by T2, okay, which is going to be 3. Common ratio R in this sequence 4 minus 2, 1 half minus half, etc. is going to be minus 1 by 2. When you divide minus 2 by 4, it is going to be minus 1 by 2. Or for that matter, minus 1 by 2 divided by 1 is going to be minus 1 by 2. Okay, the general form of a GP, how to write a geometric progression in a general form: AR square, AR cubed, etc. This is the general form. Make a note of this. With the A to the power 1, 0. Common ratio equal to R to the power 1, okay. The nth term of GP is denoted by Tn, that is equal to AR n minus 1, okay. Look at this: Tn, the nth term is going to be A, initial term, R, common ratio to the power n minus 1, the nth term minus 1. Okay, remember this is very important formula, okay. Sum to n terms. How to find the sum to the n terms of a GP? If n denotes the sum of n terms of a GP, AR square, etc. Okay, if r is greater than 1, sum to n terms, if r is the common ratio greater than 1, then sum to n terms should be gotten by the formula ar to the power n whole minus 1, okay, not n power minus 1, okay, divided by r minus 1. Look at this, okay, r. If r is less than 1, in this condition r is greater than 1, that is r is a common ratio, is a positive number. If r is less than 1, that is if it is a negative or a fractional number, it's going to be a into 1 minus r. Instead of rn minus 1, we are going to make it 1 minus r to the power 1. So that 1 minus, here in the denominator we have to give 1 minus r. Okay, this is the way we find the sum of the n terms. Or if r equal to 1, if the common ratio is 1, then sum is pretty easy, n into a. Okay, so that is it. So these are the three conditions you have to make note of. If r is positive and greater than 1, or is less than 1, or that is negative numbers, r equal to 1 is going to be easy. Okay, the sum of infinite geometric series is going to be a divided by 1 minus r. Okay, always remember infinite is, it goes on. Okay, generally a being the initial number and 1 minus r going to be the common, r being the common ratio. Okay, summation of special series, sum of the first n natural number like 1, 2, 3, n, etc. Okay, this is the thing, sigma, you have to see. Here are some of the special series under the formula that denotes sum of n natural numbers, that is starting from 1, 2, 3 plus, they add all these natural numbers to n terms, okay, which is denoted by sigma 1 to n and n here. Okay, this is the formula, n into n plus 1 by 2 for it. Okay, so now the n odd numbers, you know, 1 plus 3 plus 5 plus etc. equal to 2n minus 1. This is how you denote the odd numbers. 2 into 4, if you want the fourth term, okay, 2 into 4, 8 minus 1, 7. So anytime this formula will give the nth odd number. Okay, so if you have a sigma, that is if you sum them up, this is the way you denote. This is the sigma 1 to n, 2n minus 1 equal to n square. Okay, comma to 1. Sum of the squares of the first n natural numbers. This is the 2 1 square plus 2 square plus 3 square plus etc. till n square. Okay, this is denoted by 1 to n square. This is how you find the sum of the n squares, n into n plus 1 into 2n plus 1 by 6. Okay, sum of the cubes of the first n natural number, 1 cube plus 2 cube plus 3 cube etc. till n cube. This is denoted by sigma 1 to n cube. This is the formula to find it, n into n plus 1 by 2 the whole square. Okay, like this. Then we will talk about the hour clock arithmetic in a later time. Same thing in arithmetic progression, we found that sum to n terms can be arrived at like this. N s of n can be denoted as n by 2, 2a plus n minus 1d. This is the formula. Okay, and general form of arithmetic progression is a comma a plus d, a plus 2d, with first term a and common difference is d. In geometric progression, it's a common ratio. Here common difference, that is r, here it is d. General term of the nth term in an arithmetic progression is Pn. Okay, it is equal to a plus n minus 1d. Okay, this is the formula, general term, and the sum always denoted by, for the arithmetic progression, which looks like a plus d, a plus 2d etc. till a plus n minus 1d. if we denote like the arithmetic progression like that, for that sequence, arithmetic series sequence, the sum is going to be, okay, n by 2 into 2a plus n minus 1d. Okay, you have to complete this, then multiply by n by 2. That is n by 2, and another one is a plus 1, that is a being the first term. 1 equal to tn equal to a plus n minus 1d. This is being the last term. L being the last term. This is L. Okay, this is the nth term. This is how it is denoted. Okay, these are the formulas we have to remember.